I'm going to be talking about what happens when you do a Dagger call. And so I have a very simple example that I'll explain more in a little bit that I'm going to be centering this around. But a lot happens underneath the hood. A lot of it's pretty cool, I think. So yeah, I'm going to be going over that and hopefully giving a peek of what's actually happening inside the engine. So yeah, the Dagger engine is a sandbox, multi-language, cacheable, function-based RPC engine, which is obviously a bit of a mouthful, but the goal here is for that to actually make sense by the end of all of this. And this is very much underneath the hood. Users, you don't have to care about any of this, but if you're interested in, how some of this magic actually works, then hopefully this will help. And I absolutely have to skip all kinds of details and make a couple simplifications in a few places just for the sake of time. But I'll try to call those out. So yeah, that example I had, Dagger call check source. So this is what I'm going to be talking about. So I have two modules here. I have one that is written in Python, and it is using a tool called Rough, which is a super fast Python linter. And so just a single function, keeping it simple. It's called check. You give it a directory, which has the source code that you want to lint, and then it is going to lint that. I have here, so I got this from Daggerverse. I think Kyle wrote it, and I made a small change. It's doing a dag.wolfie.container and then installing the rough package. Wolfie is, you can think of it as a way of building base images in a super secure and customizable way. So it's getting a base container and then mounting in source and just calling rough and then giving you the standard output. But Wolfie is just another module that this module depends on. That's over here. And so Wolfie is written in Go. I think I got this from Solomon from the Daggerverse. It also has its own dependencies. I'm kind of skipping over that just to keep things relatively simple here. But so when you call Wolfie container from Python, it's actually calling this Go code, which is doing the stuff to actually build that Wolfie base image with the packages you requested. So that's the idea. And really want to explain how this magical part works. Like, how do you call Go code from Python? And, same idea for all of the SDKs that we support, TypeScript and so on and so forth. Okay, so the first thing that happens when you do Dagger call, this is before any module loading, really just at the initialization of the CLI, is the CLI needs to talk to an engine container, and that's where most of this happens. The CLI is relatively lightweight. It's mostly just a client to that engine container. But the engine container doesn't necessarily exist already. It may, but it needs to be found if it already exists, or if it doesn't exist, it needs to be actually provisioned. And so, yeah, this output is what you would see if you're running Dagger for the first time, or you just updated versions. It's what's actually happening. So there's a CLI. And this is, by the way, just a default path. There are other configuration options, but I just want to go with the default, which is to run that Dagger engine container in your local Docker instance. So the CLI, it just talks to Docker D. It checks to see, is there already an engine? If not, then I'm going to go and pull that from our registry. It's just a container image. And then it's just going to go and run that. And so then at this point, you have a CLI and you have this engine container, and it has an API socket. They haven't actually talked to each other yet, but they at least both exist now. So that's like the very early initialization that's happening. So now the CLI and the engine need to actually talk to each other. So I'm skipping over quite a few details here, but basically what happens is the CLI, it goes and connects to that API socket in that Dagger engine container. And it sets up a couple channels so that it can make requests to it, and then also the engine can actually go and make requests back to the client for things like local directories and so on and so forth that exist in the client. And specifically what it does is it sets up something called a session. And so a session is the state that's associated with one connected client. And so if you have multiple clients connecting to the same engine, then they're all going to get their own session. I'm not going to go over all the state that's associated with that, but the really important stuff is there's a GraphQL server, which is going to be the actual API that the CLI is using to actually run pipelines and do stuff. But other examples of session states, so there's a secret store that's all in memory. It keeps track of syncs of the local directories from the client when the engine requests one of those, so on and so forth. And this is up here, the output that you see. It usually goes very quickly, so it's hard to spot, but that's what's happening, is it's initializing this session within the Dagger engine. Okay, so I'm going to take a very brief step back and talk about just API calls generally, and then I'll go and connect this back to the original example. So in Python, you could do, I mean, really simple thing. You just want to run echo hello in an Alpine container. So dag container from Alpine latest .with exec, and then get that standard out. So that's the code up here. So what's actually happening in terms of the CLI is this code gets converted into a GraphQL query. That's what's here. If you haven't seen GraphQL before, it's relatively simple. It's, you have fields and then you can select data from those fields. So you're saying container, and then I want to select specifically from Alpine and then select that with this exec run of echo hello, and then select the standard out. So that's from the client's perspective. It's sending that to that session in GraphQL server that it just set up. So what's actually happening here is we have the GraphQL server. And when you start out, there's something called the core API, and that's container, directory, Git, all of the really basic stuff. And that's always going to be available to any client. And so the server goes through, it executes those. It specifically is actually sending them to something called the solver, which is a build kit. It's something we pick up from build kit. And it has all of the logic for, oh, did I already run this? I'll go check the cache. If I did, then we don't need to run it again. Oh, I need to go pull this image from a registry. Or, okay, I guess I haven't run this before, so I actually do need to go and run that container for echo hello, so on and so forth. A lot of details there, but that's the gist of it. And this solver and cache are kind of omnipresent throughout the rest. I leave them out of the other diagrams for simplicity, but that's the basic idea of just how a core API request works. But we also have modules now, and so those are a lot more interesting. So when you're doing that Dagger call check, it realizes, oh, you're invoking a module, so I'm going to need to load this. And I need to load this code specifically that is the definition of the module functions. So internally, what the CLI is doing is actually using the core API. We have core API calls that will let you load a module. And since the core API is always available, you can always load modules. I am simplifying the calls a little bit, but this is sort of the basic idea, is it makes a call to say, there's some module source code, and it is specifically a local directory in this case. You also support Git modules, which is just a slightly different argument here. But in this case, it's a local module. That's the source. And so when you want to load that source, it's going and talking back to the client saying, hey, can you give me that directory? Then you go and select as module, which means, okay, I have the source code now. I want to actually go and convert that to a full-blown module, which you can actually invoke and talk to. And so the basic idea there is that you have that source code and you give it to something called an SDK, which I'll mention briefly a little bit more at the end. There's all sorts of cool details there, but the basic idea is This is a Python module, so we're going to go and talk to the Python SDK. We're going to give it that source code. It's going to go and parse through the source code. Really, it only cares about the signatures, but it's going to go and do some code gen and then output a container that is actually invocable, which I'll talk about in a second. So now we have a module container that we can actually talk to make calls and, input a directory, get a string as an output. But now we want to actually make that available to the client. And so that's serve. And so what that does is it has the module container, but that's just a container at this point. It needs to actually know more about the function. So it's sort of like introspection. And so on a very, very high level, it says, what are your functions, module container? And then it returns, in this case, just I have a check, it accepts a directory, and then this is supposed to be string, but you get the idea. It returns a string. Yeah, so then now it knows, okay, here's the module container that I invoke. Here are all of the APIs that it is providing. And so what it actually does is on top of the core API, it sort of stitches in this new API, which in this case is just check. If your module has a ton of functions, then there's going to be a lot more there, obviously. So that was a simplified view of just loading one module. But like I said before, that rough module, it actually has a dependency on a Wolfie module. And, it's a whole DAG of dependencies, theoretically. In this case, I'm just focusing on, there's the caller, and then there's rough, and then there's that Wolfie module, which is the dependency of rough. But this can get, as complicated as you want it, really. The really important thing here is that the engine is going to handle all of that. It's going to go and follow the same process. It's going to see, oh, you have a dependency on Wolfie. I got to go load that module too. In this case, it's going to be from Git, but it's the same idea. The end result, which is kind of interesting. So the caller, they only care about rough. So we present to them this schema of just the core API, always available, and that rough API. And so any requests to the rough API actually end up getting routed to that rough container. But the rough module, it is actually just a client too. It's almost entirely the same as any other client. And it depends on the core API and the Wolfie API. So when it's making requests, we actually give it a different schema of just those APIs. And then Wolfie, in reality, it does have more dependencies, but we're just pretending right now that it has no dependencies. So all it has is the core API available. So you can kind of think of it as they're all clients, and we give them just a view of the exact APIs that they depend on. And there's a lot of advantages to doing that. It helps solve a lot of dependency hell problems. Like if we exposed the Wolfie API also to the caller, I mean, it's confusing because they don't even necessarily know Wolfie exists. They only care about rough, but it also creates all sorts of versioning headaches. But with this approach, we can avoid all of that and just give each client exactly what it wants. So then we can finally get back to the actual original call. So the client was doing Dagger call check source. And so that is getting converted, like I said before, to GraphQL query. And so that gets routed to this schema, which has the rough API. And then the engine sees, okay, I got to go talk to that rough module, which again is just a client. And so we saw that code before where that that module is calling dag.wolfie.container. And so that's going right back to the same session in GraphQL server. But now it's going to go and hit this schema where Wolfie is actually available as an API. So that's another GraphQL request. And then that will go to be routed to the Wolfie module container. And then that, continues. It can just make core API requests if it has its own dependencies, so on and so forth. Yeah, so that is the basic idea I guess a couple other things to call out is that I just visually have these all as separate, but like I said before, everything is actually connected. There's a lot of state that is shared between all of these different schemas, a lot of caching, deduplication that you get from the solver, so on and so forth. So you it's easier to visualize them as separate here, but really they have a lot of shared state underneath. Um, yeah, so that was the basic idea. There's quite a few more details that I could get into, and we probably should in more talks and probably blog posts and stuff like that. So there's a whole function input output protocol. Like I'm greatly simplifying what is actually happening when you want to go and invoke a container. It's designed to be persistently cacheable, and some of this is cached, but not as much of it as we would like. But we have plans to pretty soon be able to basically cache everything. So when you're making these calls right now, a lot of the setup is cached, but the actual invocation of these containers isn't always necessarily cached. But we're going to change that and make that something that is super easy to configure for users. Yeah, SDKs, I tried to visualize this, but it became a little too complicated. Those are actually just modules too. So when you're using the Python SDK, that is actually just a module. There's function calls for, run code gen. There's a function for give me a container that I can actually use to invoke the module, so on and so forth. So it's kind of turtles all the way down, I guess you could say. Yeah, and I definitely glossed over the fact that we are passing around directories, containers, secrets. You pass those as argument inputs and outputs. That could really be a whole talk of its own, but the idea there's this whole DagQL ID system where you don't have to pass around, literally an entire directory if you're invoking, one module with a directory that has 10 gigabytes of data. You're not literally passing that to the module container or anything like that. What you're actually doing is you're passing a recipe, I guess you could say, for what that directory is, which means it's content defined, which is great. And it also is cacheable. So then if that module wants to use that directory, it can go and make other core API calls, but it doesn't need to pass it around. It can just pass around this much shorter little recipe for this is what the actual directory is. And same idea for containers, secrets, so on and so forth. Yeah, that's all I had. It went a little faster than I thought, but if there's any questions, I'm more than happy to talk about anything.
Great. I think Solomon was just talking more about the SDKs as modules, touching on that a little bit. Oh, I think there's a question here. So you mentioned the same dependencies of different modules are cached and share state, but what about versioning? Assuming the modules 3 levels down uses the same dependency as the root one, but a different version.
Yeah, that's a really good question. Let me go back, see if I can find a good one to talk about this. So yeah, when you have one module, so let's just say rough, it had that dependency on Wolfie. You aren't allowed to have multiple. Rough couldn't depend on multiple versions of Wolfie, for example. That just wouldn't obviously make any sense. But yeah, like let's say that in this DAG of dependencies, Wolfie shows up multiple times. It's kind of hard to explain out loud, but you it could show up multiple times in the DAG, and it could be at different versions, and that's actually totally fine for us. That kind of gets back to what I was trying to explain before about the fact that each of these schemas are completely isolated to the client that they're presented to. So as long as you don't have multiple versions of the same module directly being, stitched into one schema, it doesn't matter. You can we'll give you the Wolfie version that you asked for. If some other module in the dependency DAG is asking for a different version, that's fine. We'll load it and it'll be completely isolated to just that client.